Good day, everyone, and welcome to today's DevOps.com webinar. We're excited you've joined us. Our topic today is learning how to use a time series platform to monitor all aspects of your Kubernetes deployment. Our webinar is sponsored by InfluxData, and we have a fantastic speaker lined up for you. My name is Mitch Ashley. I'll serve as your host and moderator. A few housekeeping items. The webinar is being recorded, and we will send an email following the end of the webinar with a link to the recording and to the slides. They'll also be available on devops.com. Our speaker loves questions. We'd love to have this interactive, so please enter your questions into the questions tab at any time during the webinar, and we'll be sure to get to those, or at least as many as we can with the time that we have. So let's get moving, move forward onto our topic, using a time series platform to monitor all aspects of your Kubernetes deployment. It's my great pleasure to introduce to you our speaker, Gianluca Arbezzano. He is Site Reliability Engineer with InfluxData. Alrighty, we're ready for you to take it away. Take it away, Gianluca.
Thank you, Mitchell, and thank you everyone for being here. A little bit about myself. I'm a site reliability engineer at InfluxData. My name is Gianluca Arbezzano, and you can find my rambling on my website or on Twitter. When I'm not doing dirty hacks, what I like to do is to grow vegetables, and I like to travel for fun and work. So this is me in Dublin. I lived there for 2 years, so I had to do the best to survive. So this is me doing gnocchi at home. This is me visiting the Azores. Kubernetes is over there as well. This is a very big tree. And but let's do something fun. This was me in Cuba. I was looking at the horizon, thinking about how to monitor Kubernetes and how to figure out what was going on in our SaaS offer in Influx Cloud. So I would like to take you with me to my journey, to our journey around understanding how to monitor Kubernetes, how to monitor the application that runs on Kubernetes with InfluxDB. If you are not familiar with what a time series database is, you can think about that as a service, like a database, but it is highly optimized to handle time series data. Time series data are a kind of data that moves on time and where times is very, very important. You can't have a time series data without a timestamp. So you can think about logs as a time series data, because without the timestamp, the message doesn't really have any sense. Or if you think about host metrics like CPU and memory usage or IO throughput, those metrics without a timestamp doesn't really have any sense because it's a value, it's just a number. But when you put time on it, everything starts to get a lot more sense. And application generates a lot of those metrics. Like if you think about the number of logins you get every day in your website, those are time series. Or if you have an e-commerce, every time somebody clicks the purchase button, that's an event, and an event can be tracked as a time series. So a time series database is a place where those data are well handled and stored safely on disk. So InfluxDB is one of those, and we heavily use it to store all the metrics we have. So from the host, or from Kubernetes itself, or from the application. Because what really matters when we do alerts, or when we inspect or troubleshoot an outages, is our ability to go over different metrics, to aggregate them in order to figure out what's going on. Usually the complexity is much higher, so if you look at only one single metric, it's very hard to figure out where the problem is. But everything starts to change when you can correlate more metrics that comes from different sources, maybe from the host with the one that comes from the application. So when we start to look at how to monitor a distributed system, stuff becomes really complicated, mainly because a distributed system doesn't really fail altogether. So let's think about one application that runs locally in your laptop. That's not a distributed system because it's local to your laptop. And if the disk in your laptop's crash, your computer goes down and your application stops to report. It's pretty clear that a system that runs in one single server on one single machine is just, it will crash altogether. So in a distributed system, we see all day partial failure. So a system never fail altogether, because this is one of the goals that we have when we design a distributed system, because we make it fault tolerant and resilient. With full tolerance, fault tolerance, it means that it won't, as I said, crash altogether, because it is able to handle and accept failure in some sort. So the way we do and design a system that is resilient is about two different dimensions. The space dimension, that is usually what you see in applications. So we deploy more replicas of the same application. Another way to be resilient and fault tolerance is by time. So when you do a HTTP request to a server and it fails, a good way to be resilient is by retrying it. Another important definition or aspect of a distributed system is that the normal state is very hard to define, because, as I said, it is distributed. Maybe it is distributed across regions or across cloud providers, or all over the world, and you never know in what state it is, because maybe it is working for you that if you are in US, but for people in Korea it doesn't work anymore, or for people in Europe the latency is different and your service doesn't work as it's supposed to work. So you get tickets and customer complaints about different aspects of the distributed system, just for the fact that it is distributed. And Kubernetes plays a very important topic in this conversation, because it makes the distribution possible. So when I think about a distributed system, we can think about, if you read about how Netflix does their architecture with all their microservices, that's a very extreme distributed system. But the way I see a distributed system is like the one I draft here. This is very simple. There are two databases, and this is resilient because there are two replicas of them. So it is the space dimension that I mentioned before. And there is a cache layer. For this cache layer, we don't really need to be consistent. So I'm just going to place two of them, and they are not replicated because I don't really care about the replication. The key will be populated in both as soon as they request. They will get some request. So this, for me, it's already a good distributed system with a good complexity. As I say, Kubernetes plays a very crucial role here, because before that, distributing an application was way more complicated than what it is today. Now we can create a pod, create a container, deploy a few pods, and the application is distributed at least across multiple nodes. So this is an architecture that I draft from our experience we had moving to Kubernetes internally in InfluxDB when we did Influx Cloud version 2. So as you can see, every square, it's a node in Kubernetes, and you can see that there is one Telegraph running on every node. This Telegraph is looking for all the host metrics. So each runs has a daemon set, and this daemon set has privileged, and it runs on the host network. So let's take a step back. I said a lot of stuff in this sentence, so let's go over the most important one together. I said that Telegraph in this scenario runs as a daemon set. A daemon set is a resource in Kubernetes that distributes an application across every node. So when you deploy a daemon set in Kubernetes, you will be sure that there is at least one application, one instance of that application running for every node. So this is great to deploy agents. Telegraph is our agent. It is a collector that gets metrics from a lot of different places and push them to InfluxDB. So Telegraph has more than 200 input plugins, and it supports a lot of output services. It can push to InfluxDB, obviously, but it can also push to CloudWatch or other storages. So what we do, we run a Telegraph on every host, and we configure it to push information to InfluxDB. And as you can see, there is a namespace that is called monitoring that contains InfluxDB, our time series database, and chronograph, that is our UI. So the way Telegraph is configured is via a toml file. Toml is it's a format for configuration, and there are a lot of different input plugins, as I said. Here, as you can see, I configured and enabled the CPU one, the internal one, the disk one. A lot of them are very easy to figure out by the name. So the CPU gets information about how many CPU there are, how busy they are. The disk gets information about how much space there is, the disk I/O, the I/O, so how much we write and read. There are kernel information, the memory management, so how much memory we are using. It gets information about the process, the swap, and in this case, just because we run Kubernetes, and usually under Kubernetes you have a Docker daemon running, you can also enable the input Docker plugin that looks at the socket for Docker, and it gets events triggered by Docker itself. So if you're not aware about that, if you have Docker running in your laptop, what you can do is Docker system event, and you will see that your Docker CLI will stay waiting for events. And every time you do something, it triggers event that gets logged in the CLI. So this is what Telegraph is doing. It's listening on the events, and it logs all of them as a point in InfluxDB. Another input plugin that we use when we run Kubernetes is the Kubernetes input plugin. It looks for the kubelet events. So it does the same that we do for Docker, but for Kubernetes events. So it gets the deployment that you deployed or the number of services. On when you edit a pod, it gets that you edited the pod. It's very important to remember when you deploy a daemon set as a Telegraph that you need to share some volumes from the host. For example, you need to share the root FS, proc, sys, and UTMP. Otherwise, Telegraph won't look at the, in those directory, there are the information about the process and the memory. And so if you don't share them, Telegraph will look at the one that are in the Docker image. So you won't get the right stats from the host. You will get the stats from the container. But what we are looking here is to monitor the node itself, the host. So we need to remember that we need to share those stuff. And as you can see, I also shared the Docker socket, because otherwise it won't be found, because it is not in the container, but it's in the host. Another important stuff to remember is that when you deploy a daemon set that runs Telegraph to monitor the host, you need to run it on the host network. Otherwise, it won't be able to get useful information about the network, because as it was for the volume, it won't look for the network, for the right network. It will look for the internal container network and not for the host one. Same for the DNS policy. When you deploy a pod that use the host network, you always need to set the DNS policy. Or usually you have to set the DNS policy. Otherwise, it won't be able to resolve the DNS. So when you run Telegraph as a daemon set, you already get a lot of information about the system itself, but you can do even more. So if Telegraph has an input plugin that is called HTTP Listener, and what it does, it starts an HTTP server that behaves as the InfluxDB API. So other than going from your application and pushing metrics directly to InfluxDB, what you can do is you can configure the application running in a pod to go to push metrics to the host. So as you can see in the left side, that part is a section of a pod specification. Is the part where we specify environment variables. In this case, what I'm doing is I'm sharing the status host IP, so the IP of my server, my host, and I'm using that to push metrics directly to InfluxDB. So in this way, inside the container, when your application will push to 8086, it will push to a Telegraph running locally in your host. So you will start to collect metrics from your application into the host itself. It's always good to have a Telegraph in between InfluxDB and the source of your metrics, because Telegraph acts like a buffer. So it's able to collect metrics and to push all of them together to InfluxDB. It's a very efficient way to optimize the traffic going to InfluxDB. And let's say that you need to update InfluxDB. Obviously, it really depends on timing, but ideally, Telegraph will collect your metrics until InfluxDB will be back again. So you won't lose any metrics, even if InfluxDB will stay down for a little bit for maintenance or update. This is a very simple setup, but sometimes you need more. And another way to be very, very flexible gathering information like metrics from your application is by running Telegraph sidecar. So those two approaches are not mutually exclusive, but Telegraph, as I said, has a lot of different input plugins, and you can get metrics from almost wherever you want, like MySQL, etcd, Prometheus endpoints, RabbitMQ, Redis. It really has a lot of different entry points. But every application needs to be configured to, you need to configure Telegraph to know where all the applications are. And in a distributed system, this can be very hard. So what you can do is to run a sidecar. A sidecar is like a utility container that runs in the same pod where your main application is running. So Kubernetes has this concept of pods, and pods are very important because you can run containers into them. And it's crucial to remember that you can run more than one containers inside the same pod. When you run more than one container, they share the network namespace. So it means that they can reach each other in localhost, and they always run very close to each other. So in the same host and in the same network namespace. This configuration is very, very good if you need to have utility application that enrich the capability of the main application you have. So what we usually do, we run a Telegraph as a sidecar for every pod we have. So let's say that we have an application that exposes Prometheus-like metrics. What we do is we run another container with Telegraph that is configured to get metrics from localhost, the port of the application /metrics. So it will keep going there and getting metrics out. It will collect the metrics and push them to InfluxDB. This is an example. You can see this is a stateful set specification, a YAML spec for Kubernetes. And in the container section, you can see that there are two of them. One is etcd, because this stateful set contains etcd. And it also runs one Telegraph, that is the sidecar of the main application, etcd. I wrote, almost 1 year, or almost 2 years ago, a blog post about this, and we are still using this practice all over our clusters in production. So if you need to go deeper on this topic, you can also have a look at the blog post. It's still valid and still works. Something we learned along the way is that if you run Telegraph as a sidecar for all your pod, you will end up with a very high number of Telegraph running inside a cluster. And this is great, but you need to remember that you will get a lot of them. For Prometheus Matrix, something that you can do is also to centralize the gathering of the metrics. So you will leave Telegraph able to discover where applications that expose Prometheus endpoints are, and Telegraph will pull the data from them. So this is the main difference between pull versus push. When you work with InfluxDB or MySQL or other databases, what you do is that you push data into the database because you have an application that pushes data in a database. There are other ways to interact with a database, like Prometheus is very famous to be pull, to work in a pull way. So it doesn't expect a metrics to be pushed, but it goes to get the metrics from the application. And this is very, very useful when you know where your metrics are, or when you can easily discover where they are because you can just pull them. You don't need to have all these telegraphs. But obviously, you will lose some, configuration. You won't be that flexible as you can be running a Telegraph for every application, because every Telegraph can be configured at the best way to run for the application that is looking after. So back in the day, we had, and we still get some of them time to time, like an issue. This is Ed, one of my colleague, and he opened an issue like missing metrics in production. And the problem is, okay, that's a very good issue. Like, it's a reasonably good issue, but how do I know what I don't have? So this is a very hard question to answer, because you are supposed to get those metrics and everything is supposed to work, but when you don't get what you're supposed to get, it's always hard to troubleshoot. Yeah, as I said before, pull versus push is a very common way and friction between InfluxDB and Prometheus. But as you can see, InfluxDB work in a push based, but Telegraph is very flexible and can work on a pull and push based. So if you put it in front of InfluxDB, you will have both capabilities. When I speak about Prometheus Matrix, what I mean is, so as you can see, you can instrument your application to output metrics about its internal state. And Prometheus provides SDKs for every programming languages like Go, Java, PHP, JavaScript, and so on. So you can inject the SDK and you can start instrumenting your code. But this is and the instrumentation code will be exposed as a HTTP endpoint. So the idea is that whoever pull the metric will go to the /metrics endpoint and will pull the messages and will pull the events. Whoops, I just don't know what happened. Sorry. Yeah. So as you can, as I said, if you don't like to have a Telegraph as a sidecar in every pod, what you can do is to have a centralized one that will discover where the containers are, and it will pull the metrics and will push them to InfluxDB. So the way it works in Kubernetes is that Telegraph will watch and list all the pods. It will look for specific annotation in the pod itself. So as you probably know, Every resources in Kubernetes can have labels and annotation. Annotation are key value store, like strings, that can be used by automation to do stuff. So in our case, Telegraph will look for annotation that will say that in that pod there is a Prometheus endpoint, and it will get the AP automatically by the Kubernetes API, and it will start pulling metrics from those containers. In order to do that, as I said, you need to use the input Prometheus endpoint, and you need to enable the monitor Kubernetes pod configuration. From that point in time, the Prometheus input plugin will instantiate a Kubernetes client, and it will start to watch pods. And as I said, it waits for particular labels. So Prometheus.io/scrape equals true tells the application, tells the input plugin that it tells the input plugin that pod has a Prometheus matrix. And if you need to change the port, by default is 9102, you can use the Prometheus.io/port. Let's get back to the question, to the issue that Ed raised. So how I'm gonna know if I'm missing metrics? Telegraph has a very good plugin for inspection that is called internal input plugin. So when you instantiate that, you can get very important metrics about the state of the Telegraph itself. So you can get how many metrics it is getting, how many of them gets written to InfluxDB, how many of them get lost, or how big the buffer is. And if there are too many metrics in the buffer, they will be kicked out, so you will know how they are performing. So you can monitor your monitoring system. It is very important in a distributed system to have this enabled. When we started, we didn't have this plugin, and we learned that it's very hard to figure out what's going on. So we developed it, and you can use it, obviously, because it's open source. So if you're gonna deploy Telegraph in a environment, just remember to enable it, because it's very important. So when you have all these metrics, if you're following what we are doing at InfluxData, you will know that we are developing a new language to interact with data. And this is an example of the query that we run to monitor how many metrics we are gathering and how many of them we are losing. So yeah, we do, like we take information from a bucket, the kube_infra_monthly bucket, and we arrange them and we filter them by the internal agent and by environment. And as you can see, the graph shows 2 lines, like the number of metrics that we gather and the number of metrics that we write. So we can see how many of them are dropped. Another good way to monitor Telegraph, Telegraph is very easy to run and it's very flexible, so you can run a lot of them in chain, or you can run one in front of InfluxDB, you can scale them. But just because it's so flexible, you need to monitor it. And the input plugin is a killer feature that you should have. Another one is the HTTP response. So the HTTP health plugin. So what it does, it starts an HTTP server that returns if Telegraph is healthy or not. So this is very useful. It's like a health check for Telegraph, and it's very useful because you can configure readiness probe and liveness probe in Kubernetes to tell you how it's performing and how many of them, how many Telegraph are up or down. Just a disclaimer here for who is not familiar with Kubernetes. Kubernetes has two different types. It has more than 2 now, but it has different the type of probe. Probes are way to check how a container is doing, and based on the kind of probe that you do, Kubernetes takes decision on them. So the two most famous one are the liveness probe and the readiness probe. The liveness probe checks how the container is doing. It can be a HTTP ping, or it can be a exec command. And based on the return, so if the command exit with a status different than 0, it fails. If a HTTP returns something that is now 200, it fails. And if a liveness probe fails, the containers get restarted. So it gets a sig kill, and Kubernetes restart the container and your application. If your application will be able to recover by itself, it just needs a little bit of time to back pressure. You can configure a readiness probe. So the readiness probe won't kill the container when it fails, but it will just put it out from the pool of services that gets load. So it won't really get any load anymore, so it will have time to recover and to get back in shape. When it will be back and the readiness probe will start to succeed again, it will be placed again in the pool of containers that are getting real traffic. So Telegraph has a sidecar, as I said, has a little bit more complexity, and it is a little bit more consuming in terms of resources, because there are more containers running. But it gives you a lot of flexibility and control, because you can configure different kind of you can have a very granular control over all the applications that you are gathering. Telegraph has a feature called processors, and those processors are able to manipulate application. So this is a real problem we have. So at some point we decided to collect user agent as well, because we wasn't doing that. So we instrumented our application, our gateway, to start to push user agent as a tag over all the other metrics we was already gathering. It created a very high cardinality issue. So our monitoring system were under pressure, because we had too many different user data to handle, and our index was growing so much that we wasn't able to query it. So what we did was to use a processor, and a processor convert. There are different kind of processor. The one that is in the slide is the one that takes a field, it takes a tag and it converts it to a field. So in InfluxDB, in our data model, every point has fields and tags. Tags are indexed in database, so it means that cardinality grows, and if you have a lot of different values inside the same tag, the query will slow down. But otherwise, you will have an index, so you will be able to query much faster than over fields. So fields are usually used to store values. So if I need to store a CPU metric, I will store the percent of the CPU has a value, so has a field, and I will store the host where the CPU come from as a tag, because I usually would like to group by host or to filter by host. So the host part is way more used in a query. So when you run Telegraph has a sidecar, you have the ability to set processors and pair for the application that you are running. Another processor that you can run that is very powerful to manage the data pipeline is the tag limit. So as I said, more tag you have and more hard for the database is the life is in order to handle them. So what you can do is to set a tag limit. So you can say that every point that comes from to this Telegraph will have a hard limit of 3 tags. And the one that will be kept as a higher priority are handler, method, and status in this example. So to wrap up what we learned, scaling is not a manual process. So if you are able to, when you have Telegraph configuration, they are code that you can check out in your GitHub repository, and developer can change it and they can manipulate it and they can learn from their mistakes. So you are empowering developers to do whatever they want. Obviously, this is dangerous because at some point all those complexity will go to a database. The database need to expect some good care, so you can really throw everything you have in your mind. And scaling is not something that you can say, oh, this is wrong, you shouldn't do it. I mean, when we did the user data mistake, it wasn't really a mistake. We wasn't looking for the user data. And to be honest, we also would like to have the user data as a tag, because I would like to group by user data, so I will know how many sources or how many generator of load I have. But our infrastructure, in our monitoring infrastructure, wasn't ready for that. So if you place safeguards in your pipeline with Telegraph processors, you will be able to say, okay, this is not wrong, I'm just not ready to handle that complexity. So I will be sure to scale my InfluxDB, and I will remove the processor when I will be ready to handle that complexity. When we design the monitoring infrastructure, it's really a never-ending story. As I told you, this presentation come from a real, it's the real history we had monitoring Kubernetes. And until an hour ago, we still have conversation about is Telegraph as a sidecar really useful, or is Telegraph as a daemon set the right way to go, or should we just have a centralized Telegraph that pulls metrics from all over and removing sidecars so we will have less complexity? Yeah, there is no really a answer for that. Telegraph is very, very flexible. You can place it in front of everything, or you can chain them together. It really depends on how far and how much control you would like to have. So I was speculating about this possibility to have Telegraph as a sidecar, because the deployment in our company is managed by the developer, and developers really know what their application logs or what they get for metrics, so they can really control. If they are able to control the Telegraph configuration that runs very close to their application, they can do very good tricks like processing data and manipulating data. But at some point they need to go to a database, and usually the monitoring is in our case, the monitoring infrastructure is not managed by the developer. It's owned by the SRE team. So at some point the SRE will be the one pinged and asked for why I don't see my metrics where they are, why is everything so slow. So they are the owner and they have the responsibility for it. So let's say that the Telegraph sidecars are owned by the developer and they collect metrics. At some point they push them not to InfluxDB, but they push them to the daemon set Telegraph that we spoke before, and we have that running in our infrastructure. And that daemon set is owned by the SRE team or the ops team. So in there, they can place other safeguards like the tag limits, or they can do other processing. So in this way, you will have different tier of control over the ingestion pipeline. So maybe this is too complex for your use case. Maybe this is not enough complex, but there is room and there is place where you can sit down and think about what you need, and you can almost do it with Telegraph and InfluxDB because the architecture is very flexible. Okay, as I told you, I keep saying that Telegraph is easy. InfluxDB starts as a Go binary, so it's just one command, but it's not that easy. Like monitor needs to run when you are down. And so if you deploy it too close to your application, to your infrastructure, you won't know when it will go down because the alert will never fire because it's down with the application itself. So just remember that you need to know what you are doing. So if you're gonna host InfluxDB or your monitoring system by yourself, you should try to have different infrastructure that are far from each other. You should have a different teams, or maybe you can just go and buy InfluxLab. So I also left some of the queries that we use to monitor Kubernetes. So this one is it tracks the number of pods that are restarting. And if we look that over a Windows, there are too many restarts, we send an alert to our PagerDuty because somebody should take care of it. This one is persistent volume usage. So, so the persistent volume usage in Kubernetes, you can have persistent volumes that are attached to your container. And in this way, you can store data in a place that won't expire with the container life cycle. And this is the query that we use to figure out how much you are using the persistent volumes. That's it. Any questions, Mitch, for me?
Absolutely. Thank you, Gianluca. Thank you. Good questions coming up here. First one is InfluxDB available in the AWS Marketplace or a pre-built container image on Docker Hub?
Yeah, we do both. So during the release lifecycle, we build MEI that you can find on AWS, but we also build binaries for Linux, Windows, and different architecture, and they also get pushed to Docker Hub. So you will find them there.
Okay, wonderful. Next question we have is, can you talk a bit about what options there are for acting on the metrics?
Hello?
Hi, Gianluca. Did you hear my question? I don't know if it went through.
No,
I'll ask it again.
Yeah.
Yeah, the question was, can you talk a bit about what options there are for acting on the metrics?
Yeah, yeah. In the version 1 line of InfluxDB, if you know what we are doing, you know that there is we are developing a version 2 for all the stack. So the version 1 has a very powerful tool called Capacitor. Capacitor is a post processor that listen on InfluxDB metrics and take action on them. So you can do downsampling or you can do alerts. Another way to do automation on the metrics is by using all the SDK that we have. So we have them for the version 1 and the version 2. The version 2 are some of them are under development yet, but you can use your main language to interact with InfluxDB and trigger whatever you need to be whatever you need to do. In the V2 line, we are developing the language called Flux, and it is a scripting language that is able to get data from different sources like CSV or Prometheus or InfluxDB, and you can aggregate them together, and you can also do alerting with Flux. So in the Influx version 2, there is a feature called tasks, and you can develop them in Flux and do whatever you like.
Very good, very good. Another great question we have is, have you experimented with using FluentD to send metrics to Telegraph or directly to InfluxDB?
Yeah, yes, we do that. We do that internally in our infrastructure. So we have FluentD that collects all the logs and it pushes them to. We are trying to push them to InfluxDB to dogfood InfluxDB itself. We also push them to a centralized log processor that we use internally. But yeah, it works, and yeah, try that.
Very cool, excellent, great. Next, great questions we're getting here. How can we monitor a PVC used by a particular service with different storage classes as they depend on the cloud providers?
That's a good question. Like the metrics that I showed you before for the persistent volumes, they are taken by the kubelet, so it doesn't really matter where they come from because are not metrics that come from the cloud provider. So the metrics I was telling you about are not metrics that come from let's see them. Yeah, here. They are not metrics that come from the EC2 snapshot in AWS or from the volumes in Google Cloud. They come from the Kubernetes layer. So it's Kubernetes itself that exposes those metrics. So wherever you go, this query will run.
Oh, right. So it's portable. That's awesome. Next question we have is, what does the stack do to enable automated alerting and actioning on the metrics coming in?
Yeah, this is a similar question that we I think answered before. So if you are using the version, the V1 line, you have to be fair, you have capacitor to use, but you also have Flux enabled in after 1.7. So you have both choices. But yeah, capacitor is a very powerful one but we are deprecating it to go for a pure Flux. So if you need to start brand new, I will say check out Flux, and it has post function, so you can call an external system, or you can call Slack or PagerDuty.
Okay, awesome. Another question, where can we find performance comparisons with Prometheus and others?
In our blog, in our website, influxdata.com, there are benchmarks available. So I don't remember the section, but I'm sure we will get there. So yeah, you can find them there.
Okay, great. If we have time.
I don't think we have Prometheus one, but I'm sure we have MongoDB and Elasticsearch. So.
Okay, great. We'll see if we can find that link and supply that to everyone, either before or after the webinar. Next question, what are some of the trade-offs between different ways to run Telegraph in Kubernetes?
Yeah, I don't think there is this is a very good question. I think that there is no trade-off in terms of resources. I mean, it's clear that more of them you run, more resources you will use. That's fine. But I don't think that's the main point. I think the flexibility and the complexity is what you are looking for. You should think about what I can understand, what I can monitor, and what I can figure out when it's wrong. So if you don't have the the right if you don't have the time to have all the Telegraph running and be sure to monitor them properly, maybe you should go with few of them. So you should go with the Telegraph, with the daemon set version, or you can go with the centralized Telegraph that scrapes metrics for Prometheus. It's very hard to say to answer this question, but yeah, I can say, like, Telegraph in terms of resources is very, very efficient. So that's not the main point you should be focused or scared about. It's mainly about what I can manage more than what I can run.
Great, great. You know, if I could also just interject my question I have here. I'm really interested, given your experience working with customers, knowledge of the product. Are there some best practices, kind of lessons learned that you think folks that are maybe new to InfluxDB or getting started with this will help them kind of get going faster or implement more easily, or maybe a few common mistakes that folks might make trying to monitor Kubernetes that they could more easily solve with Influx?
Yeah, that's a very good question. For what concerns capacitor, for what concerns Kubernetes, one of the mistakes you should avoid listening to this webinar is deploying Telegraph without the internal plugin enable. So the internal plugin is the plugin that gets all the internal information from Telegraph. So if you're gonna run a lot of Telegraph, be sure to have it enabled, because you will use those metrics and they will be gold. If you are new to InfluxDB, there is we have a good documentation that you can check out. There is also a GitHub repository that is called Sandbox. It's in our organization, so it's in github.com/influxdata/sandbox, and it has a Docker compose that you can run, and it will spin up all the stack, and so you will be able to play with InfluxDB or with Chronograph, this is our UI, or with Capacitor as well. So this is a very good way to start. And in practice, when you just last feedback, when you are thinking about metrics that come from your application, be sure to understand the data structure for InfluxDB, so the line protocol, so the fact that there are tags and fields and the difference, because it will be very hard to move what is a tag to be a field. So that's if you can do it right since the beginning, it will be a very good idea.
What kind of an environment, Gianluca, do you recommend folks initially working with this and kind of testing it out, experimenting, and developers set up environments on their laptops? It could be a test environment that you use within your DevOps tool chain, or maybe in a cloud instance. You talked about there's a sandbox also capability or that you have as part of the resources. What would you recommend?
Yeah, for InfluxDB itself, it can run locally, so it's very easy. And as I said, you can use Docker with the Sandbox, or you can just download all the binaries from our website and run them locally. Another good way is to use Influx Cloud. So Influx Cloud, the version 2 has a free tier, so you can register, and you will have an InfluxDB and the UI available, and you can push your data into that. So you won't have to manage InfluxDB and run it. It will be run by us for free, like for a small amount of data. And what I usually, like for example, I'm running Telegraph into my laptop all day, and I just push metrics to InfluxDB in cloud. So that's another good way to start.
Yeah, if you can, I'd love to have you say a little bit more about Influx Cloud 2.0. I know that's a new offering, a new capability. You've had a cloud offering before, but I think there's some things that are even more, make it more easily and accessible to use in the 2.0 offering. Is that correct?
Oh yeah, for sure. The InfluxDB version 1, it's you can picture it as a isolated cluster for every customer. So you like to have a new InfluxDB version 1 data cluster of cluster. So you get there, you register, and you get an IP and a link that you can URL that you can use to push your metrics into that. But it is an isolated cluster with AC2 for yourself. With InfluxDB version 2, other than deploying the V2 line, so all the new stuff, it is more like a pay-per-use setup. So all the info, like the data are isolated in database, but it's a multi-tenant solution. So you won't have your servers, you won't pay for them. You will pay based on how many metrics you pushed, and you push and you read. But if you are just a small companies or you are by yourself doing some experiment, there is a free tier, so you can just use it for free.
Okay, great. One of the things I will do too is I'm just grabbing the URL. I'll post the URL to a DevOps chat, a podcast, actually that we recently hosted, talking a lot more about Influx Cloud. InfluxDB Cloud 2.0. So I'll post that in the chat to everyone in just a moment. Another question is let me see if I can consolidate this a little bit. How does InfluxDB support multi-tenancy? Generally, container metrics are available via Kubernetes. Need privileged access. Every user can see all namespace metrics. Is there something that you do for multi-tenancy in InfluxDB?
Yeah, in InfluxDB version 1, the multi-tenancy is only for the premium, the enterprise version. So you need to pay, and you can have as much granularity as you want. So you can even lock by tag. So you can say, okay, only the user blah 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 can see the data with the tag namespace equals test. In version 2, the multi-tenancy is in by default. So there is a concept of bucket, and bucket can have users. So if you are able to split the metrics, you can have Telegraph that send metrics to different buckets, and those buckets will be readable or writable by a subset of your users. So in the version 2, the multi-tenancy is in for free.
Well, perfect. I don't know how we timed it this well, but our questions have wrapped up just in time for us to get to hit the top of the hour. So thank you so much, Gianluca, for an excellent presentation and your responses, thoughts on the questions from the audience.
Thank you for your time. It was a pleasure.
You bet. Want just a reminder, we'll send a link to everyone with a link to the recording, an email with a link to the recording and the slides. It also will be available on devops.com. I'd like to thank our guest, our speaker today, Gianluca Arbezzano, site reliability engineer with InfluxData. And of course, we thank our sponsor today, InfluxData, for the webinar. Also, I'd like to thank you, our audience. We know your time is valuable. And the fact that you would spend an hour with us, we greatly appreciate, and thank you for doing that. It's been my pleasure to host the webinar today. Have a great day and be careful out there.